down please. Fluid mechanics. Introduction. Definition please. Take down please. Definition. A fluid is a substance that cannot withstand shear stress. A substance that cannot withstand shear stress and hence deforms continually when exposed to shear. Therefore, deforms continually when exposed to shear. Full stop. That's it. To shear. S-H-E-A-R. Full stop. Next up, please. Let's look at mechanics. Mechanics is simply the study of characteristics. Mechanics is simply the study of the characteristics and properties. Mechanics is simply the study of the characteristics and the properties of a body at rest or in motion. So I'm trying to define each of these individually, right? Fluid individually, mechanics individually. Now combine them. Combine them. Therefore, fluid mechanics is the study. Therefore, fluid mechanics is the study of the characteristics and properties. Therefore, fluid mechanics is the study of the characteristics and properties of fluid at rest and in motion. So fluid mechanics becomes the study of the characteristics and properties of fluid at rest and in motion. Next up is, let's look at branches. Let's look at branches of fluid mechanics. Branches of fluid mechanics. Alright, there are three branches of fluid mechanics. Right, fluid statics, fluid kinematics, fluid dynamics. Number one, please. Fluid statics is the branch of fluid mechanics that studies the characteristics and properties of fluid at rest. That's it. Of fluid at rest. The branch of fluid mechanics that studies the characteristics and properties of fluid at rest. That's it. Next up, fluid kinematics is the branch of fluid mechanics. Fluid kinematics is the branch of fluid mechanics that studies the characteristics and properties of fluid in motion. The branch of fluid mechanics that studies the characteristics and properties of fluid in motion without due consideration to the force causing the motion. Without due consideration to the force causing the motion. That's fluid kinematics. Of course, from there you can define dynamics, right? Fluid dynamics is a branch of fluid mechanics that studies the characteristics and properties of fluid in motion with due consideration to the force causing the motion. That's for dynamics. With due consideration to the force causing the motion. For this one, we don't consider the force. For this one, we consider the force. And for today, let's start with fluid statics. Let's start with fluid statics. So we said fluid statics is the branch of fluid mechanics that studies the characteristics and properties of fluid at rest. Question: when a fluid is at rest, what are some of these properties? So, subheading please. Properties of fluid. Look at this. Properties of fluid. Look at this. They are properties of fluid. Alright, take down. The different properties of fluid includes please close the door, close the door, please, close the door. Alright, so we have about 8 properties. Let's look at these one after the other. Try to be very fast, right? Let's see what we can get. Let's start with number 1, please. Number 1, please. Adhesion. What's adhesion? What's adhesion? I'm assuming you should know this one. So what's adhesion? Huh? Similar. Alright, take that please. Adhesion is a phenomenon. Adhesion is a phenomenon where substances which are different stick together. Alright. We can say adhesion is a phenomenon where different substances stick together. That's it. We can say the adhesive force is a force that enables substances which are different to stick together. That's number 1. Number 2, cohesion. Number 2, cohesion, just the opposite. A phenomenon where substances which are the same stick together. That's cohesion. Phenomenon where substances which are the same stick together. Yeah, for adhesion, which are different. For this one, they are the same. Now, in my own way of doing things, I don't crack. Just like that man, I used to confuse between adhesion and cohesion. Which of them is same, which is different. So this is what I developed that helped me get it perfectly. So here's what I do. I say between adhesion and cohesion, I used to mix them together. Which is the same, which is different. Now this is how I got over that. I'll just say cohesion, C, the same, and that's it. So this was my trick to remembering it. If I say between which of them is the same, just say cohesion, C. Change the C to S. So cohesion, or if I say cohesive force, is a force that allows substances or molecules of the same substance to stick together. And that's how I got that matter. Alright, number 3 please. To look at this one, it's our first class, so I'm not going into them in detail. We'll use this to analyze manometers and explain some scientific concepts like why is that water wears glass and mercury does not wear glass. We'll use this stuff to explain them much more later. Let's just get definitions for now. Number 3 please, capillarity. The tendency of a fluid. Capillarity is the tendency of a fluid to move upwards or downwards in a capillary tube. Capillarity, the tendency of a fluid to move upward or downward in a capillary tube. That's capillarity. Permit me to skip this. They have calculations. So let me treat definitions first for calculation. Let me skip this. Come to this. Surface tension. Look at surface tension. Surface tension is a force that acts on the surface. Surface tension is a force that acts on the surface of liquids. I can say fluids if you want to. A force that acts on the surface of liquids or fluids, making them to behave like an elastic stretched skin. A force that acts on the surface of liquids or fluids, making them to behave like an elastic stretched skin. Skin, S-K-I-N, elastic stretched skin, S-K-I-N. Skin, this way, elastic stretched skin, so you have this. So I said, I'll be referring back to this one as we go. When you use your water tap, use water tap like this. When you use water tap there, right? You on the tap there, water is flowing out. You switch off the tap. What do you observe? If you look at here, you'll be seeing molecules of water like this. Something like this, it will be small. This stuff there does not fall automatically. It becomes bigger, and then bigger, and then bigger until it finally falls down. Now the question is this: how come this man here was, when he was small like this, why does it fall? What was holding it? Then there's what there? Surface tension. So this concept is simple. This man gets bigger and bigger and bigger until it becomes bigger than, or you can say, the weight of this molecule becomes bigger than the surface tension force. So hence, it will now fall. So what was holding this water molecule from falling initially is called surface tension. That's how it works. Next up, let's look at density. Think of this. There are three types of densities. Number one, we have what's called mass density, also called specific mass. Number two, we have weight density, also called specific weight. Number three, we have what's called specific volume. Now, observe, I didn't say volume density. I said specific volume. So there are three types of density. You have the mass density, you have weight density, you have specific volume. Mass density is also called specific mass. Weight density is also called specific weight. And then, what have you? Alright, let's explain each of them. Let's start with mass density. Think of it. This is the total mass. This is the total mass acting per unit volume of a fluid. This is the total mass acting per unit volume of a fluid. The total mass acting per unit volume of a fluid. Full stop. It is represented by the Greek symbol. This is called rho. It is represented by the Greek symbol, this one here. That's called rho. Where mathematically we have that rho is equal to said mass per unit volume. So mass over volume, that becomes mass all over volume. Mass obviously measured in kilogram, volume measured in meter cube. So please take note that the SI unit for mass density, your SI unit is kilogram per meter cube. That's your first note. Kilogram per meter cube. About two things. There are many units in this topic. I will take my time to show you all of them. Alright, take down this. Weight density. Take down. This is the total weight density. This is the total weight density. So it's also called specific weight. Is the total weight acting per unit volume of a fluid. The total weight acting per unit volume of a fluid. Total weight acting per unit volume of a fluid. Please, okay, you can add that bit. It is represented by a small w. That is weight density, small w. Small w. Mathematically, weight density or specific weight, which is small w, is equal to, we said, weight all over volume. Weight is measured in Newton, all over volume is measured in meter cube. So your SI unit is Newton per meter cube. Please get this stuff right. The SI unit for weight density is measured in Newton per meter cube. There are two ways you write, what's it called? There are two ways you write mass density. Either this as rho, like this, or perhaps either this as rho, this is rho, this is not P, see why it's called man, or this as rho. I think engineer Lou likes this one. That is what he uses. So each of them, the same thing. This is rho, the same thing. Alright, next up is relationship between, please if you have a question, ask who. Relationship between mass density and weight density. Relationship between